Well then, I shall switch into German. Well, dear ladies and gentlemen, a very warm welcome. I'd like to invite you to participate in a truly exciting discussion. We shall discuss what is actually happening in the global economy, and namely focus on digital technologies. And it is my pleasure to introduce the participants of our discussion, Deputy Minister Morozov and EU Commissioner for Digital Economy, Gunther Oettinger, is also with us. It is great to have these honorary members with us. And let me make a brief introduction, since we have a lot of different panel participants. And we also need to stick to the time regulation. So I would invite my neighbors on my left and on my right, please make sure that your speech is no longer than 5 minutes, so that other members of the discussion can participate there. So please stick to the time limits, so that we have enough time for Q&A. So why are digital technologies so exciting for us? In Germany, we have an idea of Industry 4.0, which means the fourth industrial revolution that would follow after the three previous revolutions that we've been through. And this is truly exciting. And we can say that there are basically several key issues connected with that. The first one: how does that impact the model for doing business of individual companies? Second question: there are certain strong advantages of doing business between Russia and Germany. We have a very strong base to build on, namely industry and manufacturing, that we can gladly combine with good business solutions. Another issue for discussion is whether the European economy is doing as well and developing so efficiently as in the US, whether it is a solid foundation to build on, and what exactly is being changed, how the added value is being created in this area. A lot of new things are happening, a lot of new developments are going through right now. We also discussed the issue of competition and labor efficiency, increasing the productivity, and actually first and foremost we are discussing the issue of human capital, what kind of people we need, what kind of experts are required, so that we're able to lead this constructive dialogue and secure solid growth. Now I would invite Mr. Morozov to take the floor, and then Mr. Oettinger, and further on. So now, Mr. Morozov, the floor is yours. Thank you, dear colleagues. For us, Germany is not just a very important economic, but also an industrial partner. And with its engagement, we've luckily modernized our manufacturing sector. More than half of all the import from Germany accounts for high-tech and spare parts. All in all, we have around 5,500 companies with German capital, and this is the largest business community in our country. And even in today's situation, we are finding the ways to continue this very intensive dialogue and cooperation. And I can say that the interest to the Russian market from the German colleagues and German business environment is really high, and despite all the restrictive measures and serious decline of the goods turnover. And I'm confident that these are only temporary trends. As you know, last year, the law on industrial policy came into force that clearly stated our priorities for Russia. And in that, our foreign partners received a very clear understanding what are the new principles for doing business in Russia. First and foremost, we're interested in creation of high-tech manufacturing, a full cycle with a high level of localization. And we've been consequently sending these signals to the German businesses to explain the advantages of this new investment tool, namely special investment contract. And I have to say that we received some preliminary positive feedback, and jointly with Klaus company, we're signing the very first historic contract of the kind, and hopefully in the nearest future we would sign special investment contracts with other companies, namely DMG Mori. I think in the future it would be a very good showcase for many of our colleagues. Many of them are just standing and waiting. I also would like to share with you that today manufacturing of heavy machinery is not just heavy machinery. These are driveless machines. They use GLONASS or GPS as a navigation. They're being used in agriculture in a self-independent mode. They can select the proper operation to deliver. And that kind of high-tech manufacturing is also of new technological growth, both for us and our German partners. If we take a look at the horizon over 10 to 20 years, I believe Russia can only be competitive by creating the new architecture of industry that would fully comply with the challenges of transfer towards the digital and smart manufacturing. And in this respect, we're moving in parallel to what our German colleagues are doing. What the Germans are calling Industry 4.0 is called National Technological Initiative in Russia. And within the framework of this initiative, we plan to create the proper conditions for provision of global competitiveness of Russian companies on the international and global markets. First and foremost, I'm talking about the markets where there are no clear industrial standards of new level, and we're working to create competences in this area. How can that be achieved? In Russia, we are always good at creating of pilot projects, but it would never end up in mass production. So we have to bridge this gap between theoretical science and actual manufacturing. We have a very strong segment that we can focus on whenever we're talking about transfer to the new technological solutions. I'm speaking about the development of put-through solutions for the calculations, and actually we need to create a brand new system for training of the human capital who would have to work on this new plant or factory of the future. We're still going through the deficit of mid-size and small high-tech companies. Without SMEs in this area, we cannot make this leap. Therefore, we have to work on increasing their number, and this is among the priorities of the National Technological Initiative. Talking about development of cooperation with our German colleagues in this area, bearing in mind the increasing complication of the added value chains, we have no other way to go. And the sooner we achieve these results, the more advantages it would bring to our economies in the future and leadership for our companies. Thank you for your attention. Thank you very much, Mr. Morozov. I believe these are indeed very important comments to make, and we shall try to together answer the question of the digital technologies and IT and their possibility to create added advantages for Russia and Germany, and namely how the engineers of new generation can contribute to that. Mr. Oettinger, Commissioner for Digital Economy and Society, the European Commission, you're working on many issues. Among others, you work on harmonization in the area of digital technologies and IT. If I'm correct, I believe the European Commission is preparing a number of initiatives that is going to proclaim in the nearest future and would make them public. Would you please probably give us some hints or general traits of these upcoming initiatives? What kind of documents are to be approved, and what kind of consequences can we expect for the economy and modernization of manufacturing? Professor Mangold, the Deputy Minister, digital revolution is irreversible, and its tempo is very high. We've been through a number of that kind of revolution, book printing, electricity, automatization, all that was happening, and these were indeed colossal revolution that impacted many generations, and it brought us to certain changes. Naturally, IT revolution. Well, we all believe that it is restricted to IT and TMT. Well, now it is moving on to other industries, and digital technologies are changing all sectors of the economy and all aspects of life in the society. So everything that can be digitalized is being digitalized. And if it's all happening properly, then the certain results survive, they're being transformed and moved further. If no, then certain destructive processes are simply destroying all these inventions. If we talk about media sector, it is already completely digitalized. IT sector is extremely strong. Finances and banking, insurance, automotive industry. All that is fully digitalized, machine building, and I think we shall witness in the upcoming decade that all sectors of the economy shall go through this revolutionary leap, and that would naturally transform the society as well. Our US colleagues have developed a certain strategy, and they plan to implement it in the interests of their country naturally, and they use two key tools: short trending and cheap energy. For example, if we talk about renewable energy sources, this is absolutely important. And the second trend, apart from energy efficiency, is digitalization. And they're quite successful in doing that. And I don't think that Apple or Google would still be there. Well, I think they wouldn't restrict their activities solely to manufacturing or metal processing. All that kind of digitalization would be felt by all the companies. For example, Tesla is using that kind of approach. Microsoft, Facebook, and many others are using that, and many other things, something that we're witnessing on the stock exchange market. Digitalization is impacting all these areas. Siemens, Daimler, BMW, Volkswagen, Deutsche Bank. And this list goes on and on. These are 30-plus top companies, well-known all around the world, are using these technologies from the US. For example, Google is offering us a lot of opportunities that we're all making use of. However, we're in certain dependency to Google, so not all of that can be Europeized, but digitalization is important for survival of Europe and its manufacturing as an independent industry. So digital standards and global standards should be introduced, and we as European Union coming up with an initiative to make certain steps towards our Russian partners. First of all, European project on robotics, quantum mechanics, and 5G technologies. And we'd like to invite our Russian partners to participate there. European understanding of information processing and protection, standardization in digital security. And we're trying to develop a security structure and safe data exchange in Europe. This is important to bear in mind, since when we talk about manufacturing intelligence and espionage cases, technology scouting, and all kind of infrastructure changes that should provide for safety and security in financing. And we're working to introduce the highest industry standards that are absolutely obligatory for European companies. And actually, we work to increase labor efficiency and productivity. New E-Class Mercedes. This car is a driverless car. BMW 7, Audi A8 is another one of the series. But whether it makes any sense or not, because if you're simply driving in a test autobahn from Ingolstadt to Munich, it is a nice thing to do, but this is an artificial road, so once you cross this border, it might be somewhat more complicated. Whether it is realistic to bring it into real life, whether it goes well with driving safety, whether it is a realistic idea or not. And this is exactly why we have started this dialogue with car manufacturers and their suppliers, Magna, Valeo, ZF, Alicante, Siemens and Bosch, and representatives of TMT industry. And up until now, our TMT partners were opting for the use of mobile connections and stationary phones, while now they are overtaking the role of regulation of traffic management, so that one vehicle can communicate to another vehicle, or many other issues that deserve attention. So this is an idea of interconnectivity. And the next key word is mobility. On a daily basis, cars and trucks are transporting goods from one part of Europe to the other, and despite sanctions, cargoes are also being transported to Eastern Europe, and in this respect we do not only need continental and European regulations applicable to automobile industry and trucks as such, the rules of transportation and movement in other countries.
Deswegen bieten wir unseren russischen Partnern an, dass wir
of connecting all of this into one single system, so that together we find a way to the new system of connectivity to 5G, to the 5G system. So in order to tackle issues of defense and military importance, and on the other hand, they organize the life of the civic society. Let's take the borders of Finland, the Baltic states and Poland. Now, all the European borders are to be interconnected. I'm talking, of course, about the crossing points. And this is a very good argument in favor of industrialization and mobility. Then there is another directive, Industry 4.0. Take daycare centers or kindergartens, or take whatever else which turns into a term, into a notion understood everywhere in Europe, in France or elsewhere. Or let's take some sort of intelligent or smart manufacturing in Holland or in Denmark and Germany. We would like all the EU member states to be connected to this platform, Industry 4.0. This platform, on the one hand, presents the national industrial development strategies. On the other hand, there is another aspect of this strategy, which is at the level of European standards. There is Turkey, there is Ukraine, and they have their own problems. We come across our own problems and their problems in the everyday life, and there must be a common environment for contacts between humans and machinery. There must be the information and computer language taught at school, and this teaching must be carried out at the all-European level. In this case, we will have something similar to what our American counterparts are doing. Or you can find a sort of a sandwich approach in Shanghai. The digitizing strategy should be present everywhere. Switzerland, Norway, Russia are invited into this system because the chain of added value will depend on how many of us are there within this system. Thank you, Gunther. Thank you very much for this most interesting contribution, which demonstrates to us how important it is to trade at the all-European level. We spoke about the platform we need to build together, the platform that Russia, together with the European Union, together with the German industry could work on and move on into the future. Mr. Balashov, a company that works in the field of metalworking, can it make its own contribution? And considering the aspect of digitizing, how do you go about that? And what do you do about the security measures that you take? Ladies and gentlemen, good morning. I would like to support the previous speakers, particularly Mr. Oettinger, the Commissioner. First of all, the importance of digitizing for the world. Well, we definitely go through a critical moment in the industrial revolution. We can see that the new technologies radically change the world around us. And obviously, those who can be the first using these technologies and the advantages of the technologies has a chance to win in this competition. Those who are unable to do it will lag behind, and the consequences are obvious and clear. This creates new challenges for us, for Russia, because the share of information technologies in GDP is at about 2%, contrary over the past few years, contrary to the 5% in the EU member states and 6% of the GDP in the United States. So lagging behind 8 years is not that big. But if the Russians do not take the necessary measures, then in the near future we'll be 12, 15 years behind the rest of the world in this sense. So how can we make use of the advantages of automation? Now, Mr. Mangold mentioned the importance of information technologies for metallurgical industry. According to McKinsey, the application of digital technologies in steel production could give the saving of $15 billion a year, about 110 billion through the improvement of the maintenance and repair measures, about 40 billion through the growth of labor productivity, and the rest through the better management of inventory. That's in the metallurgical sector in the world. This is very good when 2/4 of the companies in the world have negative cash flow. With all of that, no, we must say that the technologies are there. They already exist, and we already know examples when the application made it possible to reduce the stock by 20%, then the inventory by 20%, and reduce the amount spent on repair works. Magnitogorsky facility, Severstal, work on that. There are some very concrete, very specific projects with the hot rolling, for example, with the agglomeration equipment. We're planning to introduce equipment that will provide us with the information necessary to forecast the behavior of the machinery and the needed repair following the data we get from the meters and the sensors. This is all tested equipment and the tested technologies. They're expensive enough, but they promise to be very effective and very efficient. We know, according to the law of Moore, all the equipment gets cheap within a very short period of time. So this is a big challenge, both for Russia and for the rest of the world. And I'm on the side of Commissioner Oettinger concerning the importance of the industry and the opportunities and risks that this entails for the Europeans. And it's it's very good, of course, that Russia is included into the list of the European states. It's not always that we hear that, and we are happy to hear that Russia is recognized as a part of Europe. So the situation is similar in many ways. Although we are behind Europe in the sphere of industrial technologies, still there are certain similarities. There are serious challenges and serious opportunities. And the cooperation of Russia and Germany opens an enormous potential for us, potential that is not properly put into practice yet. Well, although some are saying that Germany is lagging behind in information technologies. Capitalization, as Mr. Oettinger says, is lagging behind the American companies in this sense. No, but anyway, the head of one major international mining company says that it's very strange for him to see a situation when the capitalization of all the mining companies in the world is twice lower than the capitalization of Facebook. I do not know whether it's any consolation for us or not, but anyway, it just means that Russia, Europe, industrial companies in these regions, in these countries are similar. We have an enormous potential of cooperation. Germany is very strong in industrial technologies, and the application of information technologies taken together with us can have and can give us an outstanding result. Microprocessors, electronic equipment, all this is the basis of information technologies, and that's what Germany manufactures. And there is not that much risk in that for Germany and Russia in cooperation. Rather, there are opportunities, but we need to discuss that. When we talk about Severstal and information technologies at Severstal, we mean, of course, leading companies in this field, German companies, and we probably should unite our efforts, the efforts of the EU, Russia, and the business. Of course, we need to rely on the private initiative. There is a German-Russian strategic working group, and it's very good that our German counterparts have decided to resume its work, and of course the information technologies could be part of the agenda. We could pull together the efforts of the state and the private business and create the impact altogether, saving resources and strengthening each other through pulling the efforts together. Once again, I need to say that Russia and Germany can complement each other, and in this sense, we probably have a better situation than in many other situations, and there is a wonderful chance both for Germany and for Russia in that, and we need to take use of it. Thank you. Thank you very much. Thank you for demonstrating to us that it's not only in the field of IT there are wonderful opportunities, but there are other topics that should be an important element and aspect of our cooperation. Now, we discussed industry, and now time has come, and I'm addressing Mr. Hoechbauer. Your industry has very good reputation in Europe and in the rest of the world. Some are saying that we are lagging behind in the field of IT. Is that true? What is your opinion? Or maybe we should also discuss some strong aspects and some strengths, and how can we unite IT and industries? Thank you very much. Thank you, Mr. Mangold. We have been discussing these issues with our Russian colleagues and counterparts and our clients, and all this proves that the topic of digitizing is very important. But we really have to think of how to go through the next wave, how to cope with this challenge, and we can take steps from both sides. We signed an agreement with Gazprom. We have 30 years of cooperation behind our shoulders, but now we're at a different level, at the level of digitizing. And digitizing as a bridge, that's the topic I really like. And I think this is our intention. In Russia, we would like to do exactly that. We talk about investments, about joint platform, and I would like to mention a couple of examples. we suggest new startups in Russia. We offer our technologies as a platform for further solutions in order to have special solutions, targeted solutions, covering this aspect of digitizing in Russia. We follow the happenings at the Russian market and the software companies in Russia that work on very specific topics, and they have their own competences, well-developed competences, but very specific ones. They have intentions and they have ambitions, and we can help Russian companies with dealing with those challenges, and we can help them move to the global market, and through happy we could make use of their achievements. Digitizing is a bridge, and we should focus our attention on that. Thank you very much. And there is a question immediately, a question to Mr. Polyakov. Now, if we look at the cooperation models, now we can mention your company, and you're Director General of the company. How do you think we can develop these strengths, particularly in the field of IT, industrial IT? Well, of course, considering the security measures for data protection. How can we make use of that for the benefit of the country? So I represent a software company. So first of all, I will present to you our view of the world. Now, for the past couple of years, we were talking about the Internet, the 4.0 industry, but all this is a part of the global revolution of the softwaring process, softwarization. It's a new term. Well, digitizing or digitalization is data accumulation, first of all. Softwarization is a physical embodiment of everything that is devoid of this physical cover or whatever. Look at some equipment that costs 2,000-3,000 euro, although everyone understands that the components cost 200-300 euros, so all the rest is software, the labor and the effort of the company put into this particular device. And the same is true for mobile phones. $200 or $300, that's the actual cost, but we pay so much more. And so actually the price is several times higher than the software within it. That means that in the near future we'll have to manufacture, to produce quite a lot of software. And if we take the technological singularity, it's a new term, and many are thinking about this singularity, approaching that, the production of the PEU can be actually a very strong branch of industry. The role of this industry has been increasing, and we would like to mention the role of Russia in softwarization. In spite of a relatively low percentage and share of the information technologies, the culture of software production, the ecosystems for the programmers are quite positive. And with the current exchange rate of ruble, with the current production cost, we could become one of the serious exporters of software services for software development, subscription to Germany, which is a country with a high level of primary cost in production, and to the other European Union countries. The export of IT technologies and software has been increasing over the past 5 years by 14% per year on the average, and even faster during the past couple of years. Yes, Mr. Polyakov, thank you very much. I think what you have just said is quite important, because cooperation and possibilities for this cooperation are important for software, for digital technologies. Mr. Buchele, with your assistance, I would like to move over to the following issue. You made a very interesting presentation on technologies, and those were issues well formulated with proper focuses. And we would like you to say a few words about what has been happening in the world of digital technologies and informatics. Well, I'm happy to be able to speak here. The technical and industrial progress does not exist without the new technologies, and we're among the first companies to work on the principles of the cashiering model, the pilotless transport and vehicles, and we introduced software in to different spheres of our business. And we organized the Startup Center in Munich, and young staff members absolutely renewed the technological process. We talk about the alpha and omega of the data standardization. Historically, it happens so that we manufactured finished products and we earned on that. But standardization makes the situation different. The added value actually is diversified, and then there is a question: who gets what share goes to this or that particular entity? And the manufacturer and the contractor do not exist without each other. The digital technologies change the whole paradigm in manufacturing, and all this happens in one's head.
Naturally, logistics is also important, the warehouse management, and all that can be done successfully. And the beautiful example to that is the case of Uber in Germany. Taxi business that completely changed this world. And this problem shifted to a completely different sector. We're not saying whether this Uber service is going to operate further or not. Naturally, it will. There is no way to turn time back, but there are many different aspects to that. And it is important that we keep it in our hands and do not close our eyes to that. There are all kinds of research farming, and manufacturers are always trying to purchase them because they believe that if they invest into these farms, it would be in their interest to faster manufacture new products, and the whole research process would go faster. And it's not exactly so, because all these revolution and changes should be happening in our heads, and the faster the better. To my view, we're at the crossroads right now. It is either a matter of linear revolution or exponential revolution. We have to go for either of these two roads. Until a certain moment, we can manage this process, but if we take a look at the second part of it, you will see that the tempo of development would be that fast that it would be very hard to cope with it. So it is very important that we have complete clarity in our heads what we need and what the problem exactly is. Then in 10 years, we'll be able to resolve it, because this problem of doubt and the moment of choice is extremely complicated, and we have to make this choice now. Naturally, the one who is able to make the right decision now would have a great engineering company in 35 years, and we have all the chances to do that. But the revolution is again happening in the heads of people, and most probably that would be Revolution 5.0, not 4.0, and we'll wait and see what would be the new problems in personnel management, what would be happening to labor efficiency and productivity, and so on and so forth. Mr. Grankin, if we take a look at all that from this position, How is a Russian company doing? You've created a beautiful IT platform, Internet of Things platform Go Plus. How do you position yourself and your products? You're a Russian company. And maybe you would comment on cybersecurity and other aspects of it. Good afternoon. Yes, indeed, I'm a founder of a Russian platform of Internet of Things, Go Plus. Well, very briefly speaking, our product is offering our companies an opportunity to make a soft transfer to Industry 4.0. Our key attention is focused on operation with our small and mid-sized enterprises. Thing is that Russian-German partnership has a huge potential, and we believe it is primarily focused on standardization of data transfer protocols in the Internet of Things, approval of joint standards, but in order to provide for this soft transfer to Industry 4.0, we need to have accessible software resolution focused on SMEs. Well, unfortunately, today it's only large companies that can make use of these expensive platform solutions. We position ourselves from the viewpoint of a platform that can act as a middle-sized solution. It can be combined with VIP systems in a company, and this is the key focus of our company. And we believe that everything listed above might generally result in the global introduction of Industry 4.0 in Russia. But we need to speak about standards. These standards should be approved, and a lot of companies in Russia, in Germany, in the United States are being set up to discuss the standardization platform and idea of this common protocol. We believe there is no need for further delays. We can launch pilot projects jointly with large companies. We can work on integration of such large companies like Bosch, Siemens with startups might result in a very secure way to the future. Because today, a lot of startup projects are being launched and they lack support under the cover of large companies. And we might find that kind of support from our German colleagues represented by large companies. We're ready to develop the systematic solutions, and we're very open for dialogues. Thank you for your attention. Thank you very much, Mr. Grankin. You and Mr. Buchele mentioned that too. You mentioned the issue of the scale of a company. If it is a large company, whether it is an advantage or disadvantage, can we efficiently combine large companies and small businesses? And naturally, I'm going to address this issue to Mr. Schaefer. You represent an energy sector. So what is the future? Is it some kind of smart housing or any other technologies? Who would be the provider of these services? Would that be TMT or E.ON? Mr. Mangold, that is indeed a very important question. And I think it is applicable to the whole of the energy sector. As we mentioned earlier, digital technologies or smart technologies, especially in the area of analytics and IT, are extremely important. Digitals are extremely important. In the future, 6 billion people would be connected with one another through all kinds of gadgets. Information and gadgets of the future would be digital. So we need to take an open look on this future. These are huge digital figures. How many of these devices would go to which particular sector? 20 billion devices would be all connected in the future. 1/4 of them would be focused on energy and energy consumption. It might be smart houses or some other technologies. And the energy company would be responsible for them. They would develop that kind of devices, and they would be all interconnected. Digitals and energy would be connected. Secondly, it's not only the digital technologies that define the development of manufacturing, but there are two more trends, mega trends, I would say. They are connected with energy sector and IT, namely decarbonization and decentralization. Why are we working on that? Well, because without these two components, we cannot possibly have smart internet, and I can share a couple of examples. Integration of new technologies in IT area. The pace of this development is completely different. Everything is working properly only when all these devices are managed in a smart manner and create systems. And the changes that are happening there totally change the value-added chain and the inversion within these value chains. And manufacturers of energy and energy sources are decentralized now, and all that cannot be done without digital technologies. And we cannot imagine any other combination of all these components without digitalization. These are millions of devices and millions of users. And your question, Mr. Mangold, was who would be responsible for what in this value-added chain? Well, that would be happening in a similar manner as we're used to that. These are integrated projects, and everybody would be responsible for their part. Working with data is being split into different blocks, and because of that, we have an integrated value-added chain with up to 20, 30, 100 octantas of elements. And this chain can be manageable only if it is a foundation or some kind of smart solutions. For example, Google is using a lot of data, and they use certain logics of their use, and there are many other companies that use a similar approach. And it is very clearly seen that it can be done. We were discussing different business models, and we do see that computer technologies and IT technologies result in Industry 4.0, and bearing in mind the trends that I mentioned, we believe that companies will find new ways to comply with this new reality of digital technologies and computer-based approach. And our focus should be on the fact that these companies successfully built into these processes. Thank you very much. I think these are great examples how individual companies or enterprises become modern, truly modern, by using the new models of doing business and applying new technologies. And this is a topic that we're going to discuss more than once today, no matter whether we're talking about a large company or a small enterprise. And now I'd like to address a question to Mr. Schwager. What can you tell us about the issue of digitalization? How does it impact the peculiarities of your company? Maybe at the end of the day, you would say that now we have an advantage as compared to our competitors. Well, it is easy to answer this question. We are in the chemical industry, and we are paying a lot of effort and energy to resolve these issues. Well, today you were speaking a lot about added value. And this is a very important aspect, because in order to receive profit and create this added value, we need to move from one step to another. And it is specifically important in chemical industry. The progress that you are making under the general acceleration of all the processes cannot be achieved without digitalization and IT technologies. Around 100 years ago in our company, we developed a technology for manufacturing of ammonia, and it is actually now very much connected with digitalization. This is how it is happening. We're talking about mineral fertilizers based on ammonia, and we had to calculate the value of raw materials per ton of our product. And we use it in all stages of manufacturers, and I was asked to share certain examples from our industry, and Mr. Deputy Minister touched the issue of agriculture. Well, I would say that agriculture is also developing rapidly, and agriculture is in need not only of fertilizers but also of driveless tractors and other machinery. But there is a next step in this area, and we have a separate platform for that. If we take a look at the financial year and economic growth, plant protection, mineral fertilizers, processes management, and the way to distribute these fertilizers from the machinery that is driverless and computer managed. How does all that work? And what is the way to consider any kind of emergency situation? What is the way to create environmentally friendly and attractive environment to know that this is the plot where we apply these fertilizers and do not apply them there? All that is being analyzed through technologies by computers. That is not a future, this is already a reality. And if we translate it into the language of business model, one can imagine that in the end we would be speaking not only about herbicides and fertilizers, but we would be speaking about the selling of a specific service, a service from a chemical manufacturer who knows what is the right way to use its products. And by doing that, we create added value not only for us, but also in tons of products and the money we make on that. That would be the actual revolution that is going to happen very soon. And if we go deeper into the issue of how that can be done and who's going to pay for that, for example, in the case of agriculture, in order to provide for plant protection on a high level so that it is truly done efficiently, then such aspects as IP protection, check and track systems, all that would be very important, because an issue of counterfeit is an issue for all of us, and finally everybody should benefit from the system of plant protection, and fertilizers and IP rights protection are part of this value-added chain. And the role of chemistry is very important in this respect. And we make sure that we protect a human and our consumer, but also the chemical industry as such, so that we can fine-tune and regulate this process and know what we're doing to our plants. And one more example from agriculture. Manufacturing of means of plant protection from insects and pesticides. We manufacture a lot of products for that. They are becoming increasingly efficient. What does it mean? It means that we need to make sure that our expenses are not too high. We need to develop new means to manage these processes. And we're not talking solely about computer technologies. Once we can use 3D printing to print out a model or a mock-up, we need to make sure that finally a farmer or a peasant might benefit from that. Thank you very much for sharing the cases from agriculture with us. That is indeed very valuable and much appreciated, specifically when we talk about large arable lands. Therefore, I'd like to ask an additional question. What would be the consequences for agriculture and for everybody engaged in agriculture? But this is a secondary topic. And since you are a director of a think tank, what do you do in order to support the companies doing business here in Russia? You're offering advice and consulting to these companies. What are your strong points in cooperation with other research institutions in Germany or in Russia? Thank you for the question. Good morning, dear colleagues. Now I'd like to focus on the following aspects. The first one is connected with research and development of new complicated cyber systems of Industry 4.0. Well, in fact, Russia accumulated quite excessive experience in development of a sophisticated social and technological systems, specifically in the area of nuclear research. And if we think of the case of the CERN project, well, naturally that kind of project might bring to some very serious results in the IT industry. And now we face an issue of technology transfer and IT technologies transfer from this very sophisticated industry and the application in convergent industries, namely in Industry 4.0. I'm also an employee of the National Nuclear Research Institution at the Moscow Institute. I'm very interested in this area and I'm open for cooperation, and I'm also a member of the International Cooperation Group. The second comment I'd like to make is connecting with complexity science in Industry 4.0. We cooperate with our German colleagues, namely with Professor Klaus Mangold. He visited Russia just 1 month ago, and I'd like to say that the level of sophistication of cybersecurity systems and their convergent development with nano and biotechnologies has achieved this threshold of self-regulation and self-development and self-reproduction. It reached the complexity of natural systems, and the use of natural sciences and molecular genetics, biosemiotics are very often underemphasized by developers of complicated cybersecurity system of Industry 4.0.
And continuing with the biological metaphor, I would like to say that when we discuss Industry 4.0, we often concentrate on intelligent assembly, while intelligent decommissioning, recycling, recovery is of great importance. And here, the Russian researchers in the field of nanocodes and image recognition is quite important. Thank you. Now, thank you very much. Thank you. I believe that this makes me ask a question of Mr. Schabert. You are the head of a Vossloh company, and you have close contacts with the Russian industries. Digitizing or digitalization in your circumstances, is that important? Does it decide and define your work on the everyday level with your Russian partners? And do you think both parties can gain as a result? Thank you, Mr. Mangold. Our company is a railroad company in many ways, and we have two trends ahead of us. One of these is associated with the proper functioning of the railroads without any failures, any problems. How much does the life cycle of a railroad cost? Well, of course, the infrastructure and Industry 4.0 might help us a lot. You asked me about specific examples. Here they are. First of all, two railroads form a circle, so to speak. There are certain factors that stand in the way, and Industry 4.0 can give us very good experience in the sense, for example, the degree of wear of the points and what the points do and how they behave at a certain level of wear. Now, nowadays, we can, of course, carry out the visual control, but we would like it to be very different. We would like to be able to monitor the points in a rather different way. As for the life cycle of the railroads, now, when the points are used, they get heated. A lot of energy is consumed as a result, and there is only one gauge that is used to switch on or to switch off that energy supply. But what do we do when there is a lot of sun or when there is a lot of snow? Well, the points function under different conditions. All this needs to be considered, and this is being discussed. The Russian railroads, under strenuous climate conditions with great temperature changes, make it possible for us to say that Industry 4.0 has a great future. Now, thank you very much. What has just been said by Mr. Schwager is all true. Indeed, in all these spheres, there is a possibility of applying these new technologies. We are at the threshold of dramatic changes, and the consumer for whom we work, for whom we produce and manufacture, should be able to get the best. Now, at the end of the day, I would like to suggest a business model where energy is properly used on the basis of Industry 4.0. I would like to start a discussion. We'll be happy if you ask questions. Always introduce yourself and your company. It will just make our life easier. So questions, please. With Vadim, we work in the research center, the Internet of Things. Research Center of the Internet of the Things. We work together with Vadim. I think something quite important has been left out, the analysis of data. In a company, we can certainly take certain data concerning furnaces, let's say temperature, pressure, but we won't be able to know what to do with the data. It can be hundreds of megabytes of information. So it's important to understand the meaning of the data. It's important to learn how to find the algorithm. That's something very different, and there must be integrated knowledge systems, interdisciplinary knowledge, expert knowledge. There must be real professionals, engineers, managers. So it's an interdisciplinary approach. After that, it's important to understand what management decisions can be taken or made. So there is an inside group, and you know what to do and what happens. New business models might emerge, the costs might get cut. And as for the value-added chains. Now, again, here the new business models can easily appear. So you make redundant thousands of people responsible for this or that process. You install a robot and programmers who provide services. So potentially it's possible. Germany is moving Adidas back. We heard about that, and that's because of the robots replacing thousands and thousands of low-qualified workers, because this line, which requires a lot of investment, will be an enormous payback with time. So these are very concrete applications in the real field. Thank you very much. Thank you for your question and for your contribution. I can see that there are other participants with questions. So could you make sure that your question is formulated rather briefly and always address your question to someone specifically among the speakers? There is someone in the back who wanted to ask a question. My question is to our German colleagues.
Most of the discussion is about technologies and the application of technology into Industry 4.0. But we know that every industry revolution was primarily a revolution in minds and in kind of people. So maybe the question to most of the colleagues, what are the human implications of this revolution? How you are going to change your workforce, change your management systems, and kind of what are your observations so far? Thank you.
Ja. Vielen Dank. Ich glaube, wir fassen mal.
Oh, thank you. We will collect your questions and then we'll answer your questions. First, listen to the questions. Use the microphones, please, and do not lose time with that. Thank you. Thank you. Jochen Möbels from Siemens. We're a company that invested in Russia, and at present we have 4,000 employees. We work in 6 regions of the country. In Yekaterinburg, we're quite active. We built a state-of-the-art plant there. Digitizing is most important for us, and it's important for us from the point of view of the improvement of our work. Now, challenges and technological challenges have already been mentioned. Let's take diagnostics. Without the proper analysis, without the proper business analysis, we cannot imagine further development. The same is true for mobility. We require very different capacities. Flexibility is also a requirement, and digital technologies can help with that. My question is to the Russian partners. As international investors, we really would like to expand and to strengthen our cooperation. No, digitizing is important here. There was already an example given with the railroads. But what could we do to be more active here so that the volume of digitizing in Russia goes up and reaches a very different level, so that there is a real improvement in different sectors of economy. So where else could we be together? What other contribution could we make? Thank you. Who will answer your question? Mr. Mordashov, or both of you? It was quite a concrete example. Right before we began our session here, we had a big presentation made to some of the large, heavy engineering companies carrying out together with the Russian railroads. It's rolling stock programs. Considering the length of railroads in Russia, I'm talking about Russian railroads, considering the rolling stock the locomotives in the system and the number of those. It's a very big project. For the first time, the Russian railroads are thinking of the implementation of such a big project, and this project is hardly possible without a proper software and digital diagnostics. And I do believe that signing of this contract between the Russian railroads and Transmar Holding, which is a subsidiary, and Alstom is part of that, will bring about systemic demand for the digital technologies, digital measurement technologies, and software that will make it possible to make decisions on stock, on inventory, on repair works, or rebuilding of the fixed assets, including locomotives. It's a very big project, and we invite many to take part in that. Another project within the framework of the National Technological Initiative. I think this is something that happens all over the world, but anyway, today we are focusing on pilotless transport trucks. For example, it's an after-net product. And today, within the framework of this National Technological Initiative, together with our counterparts from GDP 29, the United Nations project. We are changing the rules in this sector, and we also change the rules for the application of the innovative pilotless systems from the point of view of the criminal liability and civil liability. So we hope that by 2022 we're able to begin the implementation of these projects associated with pilotless systems. And of course, such companies as Siemens are very much welcome to take part in this work. Another aspect of work mentioned by me earlier, and counterparts have mentioned, that's precision land cultivation, considering the ambitions of plowing lots and lots of lands with a 10% increase annually. The Ministry for Agriculture insists on that. The issue of digital technologies is extremely important. We hope that our pilot project, the very first project on this particular issue, will be implemented in compliance with the approaches based on digital mapping, equipment that automatically makes decisions on and distinguishes between the cultivated plants and weeds, and decides how to use the pesticides. So all this is associated with the pilotless equipment. And together with the Ministry for Agriculture, we work on the legal norms that are so important for the implementation. This will, of course, make it possible to increase labor productivity manifold, and it will make it possible to use the equipment with much greater efficiency, the equipment that is quite high. So it's the field of real business, and of course the technologies of data transfer, sensors, meters, data processing, software, all this is very much needed, and it's a real sector of economy, and in 5 years we'll be in great need of that. And Industry 4.0 and the national technological initiatives are very close to each other, so to speak, and I know that the same is true for Germany. We must synchronize the rules and standards so that our manufacturers do not have to produce one set of sensors for Russia, a different set of sensors or meters for Europe, or with the data transfer. Again, there might be problems, but we must avoid them. So the prospects are enormous and very good, very positive for those who work in the field. Your competencies can be turned into real business. No, Alexey Alexandrovich, could you say a few words? Thank you, Mr. Morozov. I saw Madam Klaus. We spoke about agriculture, about the distance control and monitoring in agriculture. I would address Mr. Mordashov. Siemens, as many other companies from Germany, should do in Russia what they do in the rest of the world. You know very well your strengths and your weaknesses, and you should look for business opportunities. And Mr. Morozov has just described that. There are measures supported by the public sector. Even without those, we in business should always look for new opportunities, and we should make business decisions, sometimes willing to accept risk and looking for partners in Russia. Siemens, such companies as Siemens, can be suppliers of solutions, but can also make use of the scientific and research base in Russia to make your own company better. Thank you, Mr. Mordashov. Thank you. The organizers asked us to round up this session on time, because there are other events that follow immediately after this session. So I must apologize. Not everyone has been able to speak up, but you can always come up and ask questions a bit later. Allow me to mention two things. Mr. Oettinger to the left over here. Mr. Oettinger, everything that we have discussed, cooperation with Russia, Russia and Europe, Russia and Germany, all this is going to find practical implementation only if you harmonize a lot of things with Russia, so that Russia is able to take part in this whole European concept, for us to have a single platform. If this does not happen, then I'm afraid nothing is going to happen. Even within the framework of a revolution, many of the projects will never take place, will never get implemented. Then, secondly, our discussion was sort of a brainstorming today. This will be continued, and we can see that there is a lot that indicates that the classical model of industrial production gets modernized on the basis of new technologies. Labor productivity will grow if we combine traditional approaches and the new ones. And decisions are to be made now. Decisions concerning what we need for the future. Mr. Morozov spoke about the pilotless transport. Well, of course, it's a revolution in cargo shipping. The distance, access to agricultural lands, all this is a part of the revolution. So revolution is a word that can be easily applied to this fast growth and development. We all want to get advantages of this process, and the progress must be nourished, indeed. So thank you very much. I would like to thank everyone who made their contributions. I would like to thank the podium. I'm sorry there were no ladies among us, but, well, just think about digitizing.